This video covers topic 13.1 over differences of squares. So today we are still factoring. We are just looking at specific examples with these factoring problems. So for the bell work, they ask us to identify the domain and range of the function to the right. Remember that Dr. XY helps us remember domain is our x's and range is our y's. Our x's are going from left to right, so we go as far left as we possibly can, which would be the value of -6. At -6, there is a value, there is a filled-in bubble, so we put a line under the inequality. And then we go all the way out to 8. So left to right is our domain. So our x's go left to right. So in this case, we can look at the points. But my suggestion for you is always just to look at the left side and then the far right side. Remember, you can use Post-it notes or blockers if you want. So our range goes from bottom to top because our y's go top to bottom. So our y's go all the way down here to -7. At -7, there is no hole, there is no lack in value, so we put a line under the inequality. And then my y's go all the way up here to 4, and at 4, there is a value, okay? So pretty much, when you're looking at domain and range of functions like these, there's a value unless you see something like a hole in the graph. If you see something like that, where you have a line and then it comes to a hole and then it keeps going, you're to assume that they have values for everything. So pretty much you're always looking for a line under the inequality. But some of the big mistakes that we saw on a most recent test was people are using just these endpoints to identify domain and range and not the true bottom to top, left to right domain and range that we actually need. So on all of these, they're asking us to factor. My first step in factoring is to look for a GCF. I don't have one, so I can go straight to the box. My box has an x squared and a -4. My product, therefore, is -4x squared. And my sum, because they do not give me one, is 0. I go to my calculator and look for -4 divided by x. In the table, I'm looking for two values that will cancel each other out. 2 and -2 would cancel each other out, so these came from the calculator. And again, it does not matter which one you put in which box as long as you make one positive and one negative. So if you put -2 up top and 2 on the bottom, that's totally fine. It does not matter this order as long as you have a positive 2x and a -2x. From here, I take out my GCF, so we have an x and a 2, an x and a -2. So my answer for the factored form is x plus 2, x minus 2. On problem 2, I look to see if I have a GCF. There is none, so I go straight to the box. My product is -25x squared because that's what I can immediately put in my box. There is no x listed, so my sum is 0. Again, I go to the calculator and put -25 divided by x into my calculator, into y equals, and look at my table. Again, I'm looking for two numbers that will cancel each other out because there's no x value. 5 minus 5 will cancel out. So I have a 5 and a -5 or a -5. Again, the order does not matter as long as you make one positive and one negative. Take out my GCFs. I have an x and a +5, an x and a -5. So I have x plus 5, x minus 5. Problem 3, we look for a GCF. 4 is 2 and 2, 49 is 7 and 7. There's nothing that they share, so I can go straight to the box. 4x squared minus 49. Remember that your product, you always multiply these. We multiplied -4 times x squared, and we multiplied -25 times x squared. We just don't see it as visually because there was nothing to change the numbers. But -49 times 4 gives me a -196 x squared for my product. My sum, again, is 0x because there is no x listed. So in my calculator, I put negative 196 divided by x into y equals. Look at the table. I'm looking for two numbers that will cancel each other out. So basically a positive and negative. Remember that you skip over decimals and we only look at whole numbers. 14 minus 14 would cancel out. So 14 and minus 14. I take out my GCFs. I'm careful, especially because this time I have a term in front of the x squared, so I have to make sure whatever I take out can come out fully. So up and down, I can take out a 2 and an x, and I can take out a 7. I can take out a 2x and a negative 7. So my factors are 2x plus 7 and 2x minus 7. On problem 4, I have a 5x squared and a 25. This one has a GCF because you can take a 5 out of both terms. So I have x squared plus 5 remaining when I divide it out. So I can go to my box now. X squared and 5, so my product is 5x squared. My sum is still 0 because there is nothing listed. So I put 5 divided by x into my calculator. And I'm looking for two numbers that will cancel out. The only whole number options are 1 and 5 and 5 and 1. Same thing in the negatives, negative 1, negative 5, or negative 5, negative 1. And none of those will cancel. So 5x plus 5 is all I can do. I cannot use the box because there's nothing to put in the box that would satisfy those conditions. For problem 5, 9 is 3 and 3, 16 is 4 and 4. They do not share anything, so I can go straight to the box because there's no GCF. 9x squared minus 16. So for my product, I multiply them. And I get negative 144. My sum again is 0x because none of these have x's in them. So I put negative 144 into y equals, and I look for two numbers that will cancel each other out. Remember, I'm skipping the decimals. None of these have canceled. Oh, 12 minus 12. So 12 and minus 12. So again, I'm careful because I have a number in front of my x squared, so these share a 3 and an x. 12 and negative 16 share a 4. These share a 3 and an x. These share a negative 4, so 3x plus 4, 3x minus 4. Problem 6 is my last one. So we have x squared minus 81. These do not have a GCF because we have a 1 and no x's are repeated. So I can go straight to my box. My product is the negative 81x squared. Sum again is still 0 because there's nothing listed. So I put negative 81 in my calculator. Go to the table looking for two numbers that will cancel out, only looking at whole numbers. 9 minus 9 would cancel. So these share an x, these share a 9, these share an x, these share a negative 9. So my factors are x plus 9, x minus 9. Now they ask us to stop and see if we can see a pattern. So look at 1, 2, and 6. What do you notice about all of those factors? Well, all of those factors have the same number, 2 and 2, 5 and 5, 9 and 9. One of the factors is positive, one of them is negative, positive, negative, positive, negative. So the association I see here is that 81, we could take the square root of 81 and get 9 and 9. Now if we look at 3 and 4 as well, 3 and 5. If we take the square root of each of those terms, the square root of 4 is 2, the square root of 49 is 7, the square root of 9 is 3, the square root of 16 is 4. one of these terms again is positive, one of them is negative. So, if we have a subtraction with an x squared term and a number term, so there's no x term, we could take the square root of both terms and make one positive and one negative. For example, problem 5. The square root of 9x squared is 3x. The square root of 16 is 4. So we can make one positive and one negative, and that was the same answer I got. This is listed on your formula chart. They tell you a squared minus b squared, so if you have two terms, you take the square root and make one positive and make one negative. The order in which you have the positives and the negatives does not matter. Now, as you can see, if you forget this formula, you could do the box on every single one and still get the same answer. When you work on your assignment, we encourage you to try to use the pattern, because if you use the pattern, you don't have to show your work using the box. But if you get stuck on the pattern or you don't understand the pattern, then use the box to factor every one.